Hi everyone. Let's talk about Chapter 5 in the Water Treatment Plant Operations Volume 1 book, Sedimentation. We have pre-sedimentation facilities, which are debris dams, grit basins, sand traps, impoundments, and the goal is you want to get the big stuff out of there. Sedimentation and clarification basins. The removal of settleable solids by gravity to reduce the load on the filters. Again, the more stuff we can get out before it hits the filters, the better off we are. They're usually steel or concrete basins, and the metallic parts must be protected from corrosion. You know, corrosion is a big deal in this industry. We have very, very expensive infrastructure. So sedimentation and clarification basins, they could be rectangular, square, round. Like everything else in this industry, it varies all over the board. Depends on the engineer who designed the system. It allows the water to flow very slowly. That's the key right there. You want to control it to where it goes very slow. If actual flows exceed the design flows, problems develop. It's not doing its job. So what are some of the factors that can affect sedimentation? The particle size and distribution, the shape of the particle, the density, the temperature, and the electrical charge of the particle. Shape of the particle. Smooth circular particles settle faster. Temperature. The settling rate becomes slower as the temperature decreases. Water gets thicker as it gets colder, more dense. So again, some additional factors: dissolved substances, flocculation characteristics, environmental, which would be wind and some of that kind of thing, and basin hydraulics. So here's an example of a sedimentation basin. We have a settling zone, and hopefully, we're going to go ahead and basically it's going to settle down from all that floc from the coagulation process that we put it through. So that stuff is going to gain weight and it's going to settle down. So you can see the shape of the basin in the cutaway. These are actually sludge scraper arms that move around and put that sludge down through the sludge drain. So we have water that comes up in our inlet. And again, it goes in here, it settles down, and this is your decanting trough, your outflow. So again, you have a very slow flow over the edge of this little weir, and it's that top water that's the cleanest because everything else is settling down that we're drawing off. So here's one that's drained out, and again, periodically drained to inspect the sludge and scraper equipment. Again, we have corrosion factors, mechanical issues, all that kind of thing. But it gets into the maintenance and operations. So we want minimum turbulence at our entrance and our exit. Again, we want this to move slow. Sludge builds up at the bottom of the basin and is reused or disposed of. The majority of the time, it's disposed of. Technically, they can reuse the alum that we've used in our coagulation process, but yet on the other hand, that normally is not done in today's day and age. It's also used for the removal of softening sludge. So here we have a couple cutaways. Your source water comes in, you have your flash mix chamber, okay, it's mixing it all up, your floc basins. We're getting that stuff to where we've got that chemical working to go ahead and change those ions so it's clumping together. It goes into the sedimentation basins, it settles down, and then it goes to our filters. So again, here's another side, comes in our chemicals, you can see the little mixers. Okay, we've got basically our sedimentation basin here, sludge removal, okay, and it goes through. This is our clear wells, and it goes out our finished water. So there's a big commercial one. And you can see again, it's kind of hard to see, but these are notched weirs. And that water level would be right along there. These little channels and these notched weirs, the water comes from here in the big big open part of it, goes very slowly through those notched weirs, and this again takes off that clean water onto our next step of our process. So a solids contact unit is also called an upflow clarifier. We have coagulation, flocculation, the settling, which is the sedimentation, and it's all in one unit. You use a slurry or a sludge to recycle and remove the turbidity. We've got a little tilt on this. It's supposed to be straight, but anyway, it's a solids contact unit. And again, what we have is our water comes in, comes up, it mixes. Okay, our sludge goes down. The clean water then goes up. Okay, and we have our notched weirs up here. Again, it takes our clean water out, which is our effluent. Chemicals injected over here. And then our waste for our sludge. We have our sludge rakes and our sump. You know, there's another cutaway of one. And again, they come in all shapes and sizes. Rising flow rates will increase the depth of a slurry without increasing volume or density. They're operated differently during weather changes. And again, the colder the water, the denser it gets. So we have a lot of things that are affected by temperature. Operators often cannot tell what is going on and become discouraged. Okay, again, it's one of those things as an operator, the more you've done it, the better you get. And so again, don't become discouraged, but oftentimes you have to sit there and work with these and tweak them a little bit. You drain them occasionally to inspect the sludge collectors. You want to monitor your incoming temperature. You want to monitor your turbidity of water entering the basin, and also your turbidity as it's leaving the basin, influent, effluent. Jar tests, we've touched on that a little bit. Jar tests should always duplicate the chemical dosage, the mixing speeds, and the detention time. What you're doing with your jar tests in these little jars is simulating what you're going to do in that water treatment plant. Operational controls. Accumulated sludge is periodically removed for processing and disposal. Changes in the raw water quality may be normal for some plants, but abnormal for others. Again, all different supplies and sources, every system's different, water supplies as well as the physical characteristics of the plant. If changes in turbidity occur, the operator needs to verify effectiveness of the sedimentation process. Again, you're always looking at the turbidity on the back end. Lab tests are crucial. They must always be used. Performance monitoring. If source water turbidity increases, review the coagulant type and dose. Always calibrate your lab equipment for accuracy. You know, calibrations on lab equipment. Some stuff needs to be calculated and calibrated every day, as well as others that is a once-a-year calibration. So know your equipment. The operator cannot control the raw water, only the chemical type and dosage adjustments. Again, you have no control over your water source. You always want to evaluate your overall process. You want to increase the frequency of monitoring, make appropriate process changes, and verify responses. Perform your jar tests if necessary. And again, working in a water treatment plant, you're going to be doing a lot of jar tests. You want to analyze to determine the extent of the change. And again, document, document, document. You want to make your changes slowly also, because you don't want to go too far and have to try to step back. So when your source water quality changes, you look at change in source water alkalinity from chemical spills, storms, wastewater discharges. You know, right now, we have all this precipitation coming down out of the Sierras. It's absolutely crazy. These wastewater treatment plants are probably doing some emergency discharges into our local waterways, which again, that gets under the NPDES permit, National Pollution Discharge Environmental, whatever the S is. But anyway, again, that's all being highly monitored. Sedimentation operation problems, poorly formed flock, improper mixing, improper dosing, improper coagulants. Sedimentation operation problems. Coagulation may need assistance with alkalinity adjustment. And what do you use? You can use calcium hydroxide, which is lime, sodium carbonate, which is soda ash, or sodium hydroxide, which is caustic soda. All very common things used with alkalinity adjustment. So some of the problems that we can have short circuiting, water leaving the basin too soon. Water is always going to take the point of least resistance. And if you're short circuiting, it's not going through the designed way it's supposed to go through. You could have deep sludge blankets because you haven't cleaned it enough. You always certainly have to monitor that. Currents needed to promote flocculation, but can also cause problems. The currents. The influent contains more suspended solids or is colder than what's in the basin. Eddy currents from flow or water through the basin. Wind can create currents and short circuiting also. And again, you always want to be all over this. And again, your weather can really play havoc with you. The detention time. The theoretical mathematical flow through the time in a basin, front door to back door. How long does it take to go through that basin? It may not be the actual time due to the inlet and the outlet design, the portion of the basin the water flows in, and again, this short circuiting. Short circuiting is a real issue with water because, again, it's always going to take that point of least resistance, and many different things can create short circuits in your water system, in your water treatment plant. So what do we do to prevent that? Well, we put baffles in. So you have an inlet baffle wall which minimizes the density in the currents and the temperature, minimizes the tendency to flow straight through, and it minimizes the wind currents. So, by putting these baffles in these big holding tanks that we have, basically, basins, it slows it down and it controls that. We also can use tube settlers. Tube settlers literally are tubes that the water goes through, and it breaks up the flow of the water. And again, so you think about one big stream coming through water or a whole bunch of little streams broken up. And again, you basically have a situation here of tube settlers, and what this is trying to show is basically you've got an open one on the left, you have a tube settler situation on the right, and it slows the water down. Sludge pump startups. You always want to check for, on any pump startup, excessive noise, excessive vibration, leakage of water or lubricants, overheating, suction or discharge problems. One of the things that as a seasoned operator becomes more and more experienced, it's kind of like a car mechanic. A car mechanic can listen to a motor and hear things that a normal person can't hear because they work around those every day. A little whine in the water pump or the alternator or whatever. But it becomes the same way with water treatment operators and the equipment that they work with and use on a daily basis. An operator that's been working in a plant for 10 years is going to be much more in tune with the little subtleties of that plant than the guy who's been there for 6 months. Routine maintenance of sedimentation basins and equipment. Check your bearings for wear, overheating, and lubrication. Ventilation and mechanical equipment. You always want to make sure your equipment's ventilized, has ventilation. If you put a pump into a closed closet, it's going to heat up in there. The alignment of shafts and couplings. Keep electric motors dirt-free and moisture-free. Operations and maintenance stuff, guys and gals. Maintain your lubricant levels. Preventative maintenance programs are ideal. You want to have a very, very structured operation and maintenance and preventative maintenance program. It's going to make your life a lot easier, even though it may be a lot of little ongoing work that you have to deal with. But believe me, it beats the heck out of catastrophic failure of a piece of equipment. Launderers and weirs. Okay, these are launderers and weirs, and you see the notches. See how the water draws off and clean goes through into those little channels and gets siphoned off. They uniformly collect clarified water. Clarified water, again, is the purer water. That's stuff the clean water. The V-notch weirs usually attach for uniform draw from the basin by controlling the flow. They're very flow specific. They help balance the basin, the flow, preventing high velocity and flock carryover. Okay, this is actually, in the water industry, the only time we've talked about that 0.785 figure and how we can go ahead and basically take that square and make it into a circle on pipes or tanks. This is actually the only place that you will use pi. Is if a sedimentation basin had a diameter of 50 feet, how many linear feet of weir does it have? So there you go. And that's the end of that. Hopefully, again, you picked it up. Watch it a couple times. Have a great day. Bye-bye.